We're gonna give it a couple of minutes, ladies and gentlemen, till the late comers get admitted. So I'll ask for your patience for a minute or two. Hi, Donna.
Hello, how are you?
Good to see you.
Good to see you. How are you? Thank you for doing this again.
Why aren't I getting anything?
There's still some people that aren't muted. If you wouldn't mind, that would be appreciated. John, I think you're one that's not muted. There's still some people muted. If you would, that would be appreciated. John, I think
Ray, you might have the option of forcing everyone on mute and also everyone being mute on entry.
Jolion can do that.
Yeah.
Okay, 2 minutes and I'm going to start things up. I'd like to welcome each and every one of you on behalf of myself, Ray Hill, and my partner in crime, Jolion Ralph, who takes care of the technical and is kind enough to give us the Zoom time on his own license. So thank you very much, Jolion.
Welcome.
And who's also archiving. Just a quick question. How many do we have archived now, Jolion?
I don't know. I have to go and check later, but I still have a bit of a backlog of them to work through.
Yeah, we're up to number 10 here now. So at any rate, thank you all for giving us some time in the middle of the holidays and on a Sunday. It's awesome to see you all. Sort of sad in a way because the gem we're talking about is not necessarily the most desired of all the gems that we know about. And that may be the reason why it was hard for me to find a speaker for today. So I ended up being the Joe. But at any rate, we're very, very fortunate to have you to join us, and also to have with us Dr. Phil Belly. Dr. Philip Belly is a professor at the Department of Earth Sciences at Memorial University, Newfoundland, Canada, where he leads a research lab working on solving major challenges in the areas of gemstone geochemistry and gem deposit exploration. He has been involved in gemstone-related geological research, exploration, test sampling, and consulting on a wide variety of gems, including sapphire, spinel, iolite, hessonite, rhodolite, garnets, amethyst, and opal. And he's best known for his research on sapphire, spinel, including cobalt blue, and lapis lazuli, we can imagine that, in the Canadian Arctic. In 2017, Dr. Belly and his collaborators developed a new and simple, cost-effective method for gem quality peridot exploration in BC. So of course, he's the ideal guy to talk to us about peridot. So peridot is an unusual gem. It's a gem that is found terrestrially in many locations, but also has the unique property of being the only cut gem in the known world to be found in extraterrestrial sources from palisite meteorites, which I'll talk about later on. So without any further ado, I'd like you to mute and welcome mutely our guest speaker on the geology of peridots, Dr. Phil Belly. You can unmute, Phil. There we go.
All right, can you hear me? Yeah, all right, thanks, Ray. So I will be covering peridot geology, and I won't be touching on extraterrestrial peridots because they're not a major source of gemstones on the market today, but Ray's going to handle that. So let me just, there's some stuff in my way here. Okay, here we go. So about me, I'm a professor at Memorial, as Ray said, and I'm in charge of the Gem and Mineralogy Research Lab. Well, I guess Ray did a pretty good introduction, so I'll just skip that. And I also have a website, gem-science.org. And so my latest research is available and updated regularly. So if you're interested in that, then you can check it out. And there will be some interesting spinel research coming out, hopefully in fall. So peridot is gem quality olivine, and it's forsterite dominant. So it's a magnesium iron silicate with more magnesium than iron. It ranges from yellowish green to green with a 7 Mohs hardness. It's very common in ultramafic rocks and is a very major constituent of the Earth's mantle. There are 3 types of hard rock deposits for gem peridot. And so the first one is volcanic, which is basalt hosted. The second type is plutonic, which is peridotite dike hosted. And the third one is metasomatic. And of course, there are some rare alluvial deposits. So in terms of volcanic deposits, peridot occurs in peridotite xenoliths. So they're fragments of olivine-rich mantle rocks that were carried up by the magma. And because of that, they're fragments of a solid rock. We don't get euhedral crystals, or at least I've never seen any. And they're hosted in a type of basalt called alkali basalt. And these typically occur in rifts, including back arc rifts, and also in hotspot volcanism. So here's an example of an alkali basalt. And you can see the kind of round green things are peridotite. And so this basalt here erupted about 15 million years ago in British Columbia. So most deposits of peridot are fairly young. I'd say less than 100 million years for the most part. So in this case, this sample from peridot, or from BC, for example, formed in a back arc rift. So you've got a back arc convection cell, which leads to upwelling of the mantle. And when you get that, you get a lowering of pressure, which causes partial melting of the mantle. And this partial melt is essentially the alkali basalt magma. And this carries pieces of the upper mantle with it, sometimes if you're lucky, and then extrudes them up on the surface where we can easily go and collect them. So one, I guess, kind of cool example of peridot is the green sand beach in Hawaii, although it's pretty fine grained, so there are no gems. And this is a hot spot. As far as I'm aware, there are no hotspot alkali basalts that do produce economic quantities of peridot. So they mostly come from rift settings. So important deposits that are the volcanic type that have produced commercially are the Peridot Mesa in Arizona, probably the most well-known one. The Fuli Peridot mine in China, which I believe is ramping up production at the moment. And then Vietnam also produced a surprising quantity of peridot. And there's also noteworthy occurrences around the world which have occasional production, very small scale, and they tend to have much smaller cut stones. So we've got BC, Canada, Norway, Australia, and the Southwest US, and a bit in Mexico as well. I'm sure there are a lot more. This is really the most common type of gem peridot deposit, but they are, generally speaking, limited in size compared to the other types of deposits. So, you know, a very large stone for this type of deposit, like unusually large, would be in the 40 carat range. Now, plutonic deposits, I think the only one that's really been studied in detail and demonstrated as being plutonic is the Zabragat Island deposit in Egypt. And it occurs in a pegmatitic, so very, very coarse-grained peridotite rock containing abundant open cavities. And in there, you get euhedral gem-quality peridot crystals. So not only do you get good gem rough, you can get some really amazing specimens, which I'm sure Ray will show later. So this pegmatitic olivine dike formed from magma in a host of upper mantle peridotite in an oceanic rift. And these mantle rocks were later uplifted. So if you want to read more about this, although it's pretty technical, there's Bonatti et al. And Karat et al. And they have studied and basically built a deposit model for this locality. So here's a really nice large gemstone. So again, much larger than what you'd expect in a alkali basalt hosted deposit. So 285 carat peridot, which was featured in Gems and Gemology in an article by Edward Gublin. And now the last type of in-situ deposit is metasomatic deposits. And so I think the only example of this is Sapat, Pakistan. And here again, you get euhedral to, well, sometimes subhedral, which means a bit rounded crystals of forsterite. And some of them get quite large. So you can get large gemstones on the same order of magnitude as Egypt. But these ones are not hosted in open cavities. They're hosted in serpentine, brucite, and calcite filled veins within peridotite. So they occur in a mantle peridotite, essentially, that's been uplifted. And then during metamorphism, stress opened up some gash veins. And these were infiltrated by CO2-rich fluids. And so this process of infiltration and chemical reactions transforming a rock is called metasomatism. And so they were infilled with serpentine, brucite, calcite, and forsterite. And so, calcite, serpentine, and brucite really kind of cede their shape to forsterite. So it's a great environment to get nice, well-formed crystals. And so here is from the paper Bouilal et al. In 2012. There are previous hypotheses on how these veins were generated, or how the deposit was formed. But to be honest, I disagree with them strongly. And I think this paper has really demonstrated well and accurately the most likely origin for these deposits. So here's a gash vein, the white stuff, which is calcite, brucite, serpentine, and there's a bit of magnetite as well, which is a common inclusion in these olivines. And then on the right, you see the vein material by itself with the gemmy peridot in it. And you can see the host here is just massive dunite. Dunite is a rock composed very dominantly of olivine. So the last type is placer deposits, and they're pretty rare. One reason that they're rare is that olivine and acidic environments and oxidizing environments at the surface don't play very well, so they tend to alter fairly easily. But there are some, and so one of them is Vietnam, and there are heavy mineral-rich layers within alluvial sediments, so river sediments, that locally contain economic concentrations of gem quality peridot, and these were eroded from alkali basalts. And if you want to read more about that, there's a great article in Gems and Gemology that came out in 2016. Now, I think there are placers in Pakistan near the main in-situ deposit as well, but there's little published information, and so there's not much to cover because I don't know the nature of these placers. So are they river sediments, or are they formed from downhill erosion? I don't know. Now I'll cover some research that I did in the last few years. If you want to read more about it, there's an article published in Journal of Gemology. And so what we did essentially is develop a new method to explore for gem peridot in British Columbia using a camera drone and geospatial analysis. So the study area is around there in southern British Columbia, Canada. And so the yellow here is the chalcodon group alkali basalt. So as you can see, it occurs over a huge area. And you probably wonder, how would you explore that? And now keep in mind that most alkali basalts contain no peridot. It's not really clear why some alkali basalts contain peridotite xenoliths or not, and why the abundance varies so much. But there's some data from Arizona that suggests that in some volcanic flows, they tend to sink down to the bottom of the flow, which can be several meters in depth. And so you might expect to only see them in one layer of the slope. So anyways, so most alkali basalt exposures contain not even any peridotite xenoliths. So where do you start looking in this like several 100-kilometer area? And like basically it's like, you know, these are very steep mountains, very difficult terrains, very remote. There's bears and whatnot. So how do you explore in the laziest way possible for the least amount of money is the goal. So what we did is we extracted probable exposures of basalt using geospatial analysis software. And so what we did is we looked at, so with different rock types, you have the formation of different angles of slope when they erode. And so because you've got a lot of variation in elevation, you have very steep cliffs in a lot of areas. And some of these cliffs cut through basalt. And so what happens is it cuts through basalt, and then the basalt naturally falls on the ground, and it makes what's called a talus. And this talus is generally over a certain angle. So what we did is we used this angle plus an overlap with the formation and some other criteria and proximity to infrastructure, so that it's actually possible to mine the deposit if it's discovered. And then we extracted all of the potential localities, which we then compared against Google Earth, because sometimes you get really steep cliffs of glacial till, which has been deposited for tens of meters over the basalt. So you have to take those things out. So after that, how do you explore? Like, we have so many exploration targets all over BC, and hiking to these places is no small task. So our solution was to use a relatively inexpensive camera drone. And so we purchased one of those and then set out to test on a known occurrence. So here it is launching from the road. And so this is a logging road. There's logging roads throughout the province. And so they're a really good way to get at least closer to a lot of these sites. But as you can see, there's still some snow on the ground, and the exposure itself is much higher up. So we actually couldn't hike there. So here it is going up. And then looking at the locality, which is just on the little mountain there. And you can see the snow there. The snow is about between 5 and 10 feet deep. So it's really not hikeable at that point. But you can see just on the bottom of the mountain there's a black spot, and that's exposed basalt talus. And here's the mountain, it's called Lightning Peak. So here's the talus, and thankfully it's well exposed with no snow. And so we took the drone down as close as possible, which I think this was about 3 or 4 meters from the talus itself, although it's at an angle, so it's kind of hard to tell, but it actually works. So you can see the peridotite xenoliths. Now, this is what we're looking for, because you always have a very large abundance of xenoliths, and only a small portion of those actually contain gem material. And this is true at every alkali basalt locality. So we estimated that less than 2% of xenoliths contain gem quality material. So most of them are too fine grained, and so they're not of interest. So if you have an economic deposit, then you'll probably have a very high volume percent of xenoliths within the basalt itself. So in the case of China and Arizona, the abundance by volume hovers from 20 to 40%. Whereas this spot is a little bit too poor, and it's usually around 2 to 5%, depending on where you are in the basalt flow. So then we were exploring for new showings, now that we basically proved that the technique works. And so you can see here a recent rock slide, and then the talus. And going in with the drone, you can actually see peridotite here. See, it's kind of weathered, and it weathers into kind of a hole, and sometimes it turns a bit brown. So that's the natural weathering of olivine. And it's one of the reasons it doesn't survive very well to form placer deposits, in contrast to very chemically durable gemstones like spinel or corundum. So we found some pretty good ones here. And so this is a peridotite xenolith with facet grade peridot, and I think we got, so this was just a small chunk of a very large kind of basketball-sized xenolith. And so in total, we got about 5 times that in size. And I think we produced something like 40 stones over 1 carat. Nothing over 2 carats, but still good. It paid off my drone because I was a student at the time. So I was happy about that. And here's a really nice single crystal. So this is the new occurrence. And this is the occurrence we did the testing at. And what's weird about this spot is most of the gem material occurs in xenocrysts. So they're a single large crystal of olivine, which contains the gem material. And the xenoliths tend not to contain gem rough, so they're too fine grained. And so here's a really big xenocryst. And so you can see on the top of it, it's finer grain. So that was like rock. But on the bottom here, while it's been eroded out, this all crystallographically aligns. So this is part of a single crystal. And unfortunately, most of it, again, was weathered out by freeze thaw and whatnot. So I think I got 6 or 7 really nice stones in the 1 to 2 carat range. But regrettably, I think I probably would have had more than 40 or 50 if it hadn't been eroded away. So here's some of the peridot rough from British Columbia, and some very nice stones and a very nice rough that I kept as a specimen. And you can see the spinels here, black spinels, which are very common in peridotite, basalt-hosted peridot, and also basically lily pads. Yeah, so the rough here is 2.5 centimeters across, and the cut stones up to 1.3 carats. And the great photo, of course, by the well-known Michael Bainbridge. Yeah, that's it. Are there questions, or are questions going to be at the end, right?
If people want to ask questions right now, that'd be awesome, because your presentation is fresh in their minds. So I would open the floor to questions at this point. So if anybody wants to unmute and ask a question directly, please feel free. I'm deafened by the response.
Are people able to unmute themselves?
Oh, sorry, it's
Okay.
me. Sorry, this is Reza Piroznia. I just had a question. When you cut the peridot, do you have to consider direction of cutting, or you can just cut any direction?
That would be a question for Ray. I just specialize in finding stuff.
I would say that
Thank
the
you.
cutting is really the purview of the faceter themselves, and you're going to be careful because of the cleavage capabilities of peridot. But generally speaking, you can cut it in any direction as long as it's clean. And so you want to cut it maximally for your yield as well as for light return, because this is a stone that has relatively good refractive index. And so if you can get a clean stone, you cut it as big as you can, and you cut it with as much depth and facets on it to get as much light through the table as you can. Hope that answers your question.
Thank you.
Hi, Phil. It's Bob Beckett. Are you still doing any active work in BC on peridot?
No, well, there are some sites I was hoping to look at, but overall, the concentrations of xenoliths were not very high. So I'm not sure whether there will be major deposits there or not. The area to explore would be kind of the central BC instead. We were doing south central. So there's a lot more basalt in general in those areas, and there's a lot of nice cinder cones and whatnot. So, you know, that's like basically untouched. I haven't been there at all. I probably will never have the time because I'm so busy to go look at it. But it would be something to look at for sure. So the stuff around like Nechalaco River and whatnot, and a bit south of that.
Okay, thanks.
Any other questions? Well, if not, I'm now move on to the scary part. Well, I'll present to you a little bit of what I found out about the gemological aspects, and some of the cultural history associated with peridot. If I could screen share, please. Oh, come on. Trying to get it to go full screen here. There we go. So starting off with a picture that was credited, I credit it to Clemens Schwarzinger, who's a professor of gemology and mineralogy in Germany, I believe. And he's a very good cutter. And this rough is from Pakistan. So I just want to give quick credit where credit's due. Historically speaking, we're looking at a stone, we're looking at a gem that has been mined for, and we do have evidence of it's being mined for almost 4,000 years. And as far as we know, the original mining was done in this fog-bound, very dangerous to find island, which is called Zabargat or St. John's Island. It's also called Death Island and a few other great names because of its extremely hostile nature. And it's we'll talk about it a little bit later, but this is a stone that has very interesting history, and we'll talk about that. The mineral olivine, as Phil's already told you, is the mineral of which peridot is the gem form, and it's found in almost every continent in the world. I don't know at the moment of anything in South America, but that doesn't mean it doesn't exist there. The best examples we know of for commercial gems are Egypt, which is sort of past tense, Pakistan, which is very present tense, Myanmar again, and China, which is growing. Tanzania, not very much, USA, some, and Australia. I couldn't get any data on Australia, but Vietnam as well, as was mentioned by Phil. And of course, the exciting thing to me as a collector is this is the only gem that's also found in space-derived meteorite material, and in particular, a very rare form of meteorite called pallasites. Trouble is that the nodules or the crysts, if you want to call them that are resident in this nickel iron and stony meteorite form are very small, and so they only cut usually in sub-carat sizes. I haven't seen too many that are actually in full carat plus sizes. So what are the characteristics of peridot, the gem? Well, its color generally, it's one of the unusual stones who is one color, basically one color, and it's yellow to yellow green and olive green, but always something with green in it, green with brown tones. And from a cutting standpoint, it can be a little bit of a challenge because it is strongly doubly refractive. The luster is vitreous, which is sort of like quartz, to oily, which is like you see on amber. And the specific gravity is not that heavy. It's a relatively light stone, and the refractive index shows promise from 1.64 to 1.7. So you can get some good activity there if you cut it right. Got very pale pleochroism, which is very weak, and from pale yellow to green, even to yellow orange. And in one case, in one of the pallasites, it was actually red, which I thought was very unusual. The inclusions are the classic lily pads, which you saw an example of, which is sort of a circular crack inside the stone, which usually has a chromite center or a darker center. And also there are some right-angled fine needles that are found in only the meteorite-based palisite gems. So it's actually a very defining inclusion. And the hardness is 7, as was mentioned by Phil, which is the same as quartz, which means it's suitable for most jewelry. Now, this is a question that I always try and find out about in each and every gem. And most sources that are commercially online try and put out claims that they don't have any heat treatment. Then some say, oh, we may have some heat treatment, but heating is natural because this is a stone that came from heat. I don't know if I buy that, but it's interesting because it is, I think, when it's done to try and increase the quality of the stone. And I think primarily it's probably used on stones that have brownish overtones to try and turn them into more green. And they do it by heating the stone to 1470 degrees Fahrenheit for about half an hour. And I suspect what this does is changes the energy state of the iron. It's intrinsic to the structure of the stone, and thereby changing the color. And this, you can see this kind of change of color with the changing energy level on the iron in tigerite, because it go depending on the heat state or whether what it's been heated to, from yellow to red to blue and so on. So those are all different states of the iron that's in the structure. But I couldn't find anything. Hopefully someone maybe can correct me or add to this information about how you actually can define a treated or non-treated, heat-treated peridot. And it doesn't mean that it doesn't happen. It's just, it's not out there. I just couldn't find any. But I imagine, though, it would be visible in terms of the alteration of the shape and of the inclusions, because sometimes they get deformed by the heat treatment. Now, as for synthetics and simulants, so the trouble is this is a stone, for the most part, that's very inexpensive and affordable. So the efforts to make synthetic peridot available are certainly not going to meet with a lot of money involvement, because people can get good quality peridots without having to, spend a lot of money. And obviously the synthetics are of higher quality, they're clean and have good color, but they're just not commercially viable. And I haven't seen anything out there in the sales anywhere that I could find it of available synthetic peridot. Although if you want it for research purposes, I think it's available. And of course, it's always been simulated in birthstone rings and pendants and that sort of thing, using synthetic sapphire colored green color, or glass, or paste, or even synthetic spinel. And so there are a lot of light green looking fake simulated peridots out there that people have bought over the years because they didn't want to pay the extra money for a little tiny peridot to put in their ring. But again, I think this has gone by the board because peridots are relatively inexpensive. So what do we have? What's the availability of sizes in this stone as a gem? Well, because of the nature of the geology of the peridots, some locations only yield very tiny stones up to maybe 5 carats, and others, as was mentioned by Phil, 40 carats and beyond. So Hawaii is not really a viable commercial source of peridot, but there have been some cut from Hawaiian materials. San Carlos Reservation has been an extremely constant contributor to the available stones in the market, and oftentimes their materials have been put forward as those of other more expensive locations because they do have good color and clarity. And the small stones, smaller to mid-sized stones, are also found in China and Tanzania. However, Pakistan and Egypt, although that's more past tense, Myanmar, have all yielded larger stones. But generally, stones are in the under 5 carat range are easily and readily available and aren't too expensive, and just start to get more expensive as you surmount that 5 carat level, because you start getting fewer and fewer of those available in the world scene. But good color and clarity demand higher prices, and some of these stones from Myanmar and from Pakistan are commanding good dollars and can be up to 30 and 40 carats if one wants to wear something that gargantuanly large. As far as I could find out, the largest recorded cut peridot resides in the Smithsonian in Washington and is a massive 310 carats. But as you saw in that earlier picture, there was a 286 carat, I think it was, one that was in the article that Phil talked about. I've got a problem here on my screen, Jolene. I'm getting people's pictures on the side of the full screen. Is that showing and everybody else's that way, or is it in the middle of the screen?
Yes, it's on everyone's, but I don't think it's not taking up a lot of room, so I don't think it's a problem.
All right, well, I just was worried that people were getting to see the whole screen. Some random factoids about peridot. It is August birthstone, and the thing about birthstones, a lot of people don't realize, where they were originally a byproduct of the traveling itinerant Jewish gem dealers around Europe, and they were into that trade quite heavily. And as people got used to their gems, they had to try and make them a little more interesting and attractive. So they gathered superstitiously associated properties with different stones, and then told people, if you wore this stone in the month that's from the month of your birth, then you'll then benefit from those magic qualities. Again, we're not really that believing in that sort of thing anymore, but you never know. It is, believe it or not, the national gem of Egypt. And it's been written in the very earliest writings about gems, and those of Pliny were included. And he did make mention of them mostly as chrysolite, I believe, which is really not, it's because it was found in many yellower looking stones. And chrysolite really is more like topaz in the real world. And it was believed to sharpen the mind and give one inner radiance, as well as heightening awareness as part of these magical properties, and help you think better. And it's been found in jewelry from the second millennium BC. So it's been around a long time. It was held in great esteem and was the favorite stone of Egyptian pharaohs. And there was an example I saw in literature of a carved image of Cleopatra in a peridot gem, which is clearly of an age. And they had the royal gem cutters working on it, and it was included in many of their own personal jewelries. And of course, if one is a biblical scholar, one will know of Aaron's breastplate. He was the high priest, and he basically had a stone on each of the 12 squares of Aaron's breastplate, each one representing one of the 12 tribes of Israel. And peridot was believed to be one of those stones, although many people in early times believed it to be emeralds, but I don't think emeralds were available to that part of the world in those days. And so most of the scholars disregard this and believe that it was probably a peridot. Now, Zabargad, also known as St. John's Island, Topazios, Death Island, and a few other interesting names, is the original location for most of the early location, the early mined peridots, and this is going back, as I said earlier, 4,000 years of mining. Has been intermittently mined by the Egyptians, the Romans, by pirates, by British and other entrepreneurs over time. And these are two stones I'm quite proud of, because it's very hard. It's almost as hard to get a St. John's Island a St. John's Island peridot these days as it is to get a palisite peridot, and they're extraordinarily expensive because of their rarity. And in the early 1900s, there was quite a bit of mining activity. So in early collections and early jewelry, Victorian and otherwise, there was quite a lot of peridot. But nowadays, it's very hard to get. And so I've got a fairly good sized crystal, 33 plus carats, which is nicely formed as a crystal. It has a mineral collector. I find that very attractive. And a 9+ carat cut stone that was, and I got the rough from Stephen Kotlowski's collection and his estate, which because he was one of the world's foremost gem cutters before we passed away. But because of the remoteness of the island and the fact that Egypt strongly protects this particular area, there's been very little, if any, coming out of material coming out of St. John's Island over the last 60 years. And I would say that most of the material that's out there right now is in collections is stuff that was available 60 or more years ago. I've seen a couple of articles of people who've been there, and talked to some people who've actually made the very perilous journey to the island, only to find very few and not very good quality crystals. And so I'm very fortunate here to have some images from the British Museum of Natural History, thanks to Robin, who's the curator there. And although this location has been lost and found many times, the crystals that are shown on these images are ones that came out in the early 1900s. The big gem on the left, which is 146 carat stone, was acquired in 1932. And the one in the middle, which is an enormous 686 carat crystal, which is quite gemmy, was acquired in 1924. And the crystal on the far right, which is somewhat akin to the size of the one I just showed you from my collection, was 3.5 centimeter. It was acquired in 1908. So the difficulty with this location is that it has no natural sources of water, and there's virtually nothing that lives on this island. So when the people were brought there to mine it, they worked on the most extreme and harsh conditions, which I think reflects an awful lot of the locations where peridot is found, actually. But harsh working conditions were extremely high heat, very high humidity, and no water to drink. Anything to sustain the miners was brought in, and because of the dangers of accessing the island, sometimes the miners starved because the boats weren't able to make it in safely because the island was fog bound and it's surrounded by dangerous reefs. As was described earlier by Phil, the tectonic activity in and around St. John's Island meant that the deposition of crystals was done in crevices and cracks and cavities, and so they got to be some of them got to be quite a large size, and were quite euhedral and easily appreciated by people who collect crystals. But from the gem collecting standpoint, it meant you have much larger potential for getting good quality large gems, and St. John's Island peridot is actually considered by many to be the standard against which other olivines and peridots are compared, because the color is quite saturated and quite good. Now, China's been becoming a new player in the world market of peridot supplies. I could only find 3 references to locations of significance in the literature about China. Hebei province has mines that produce sort of a chartreuse green with a strong yellow spectrum, and their stones, and they are of reasonable quality. Chiangbai provincial mines also produce bright, intense green stones of fairly high quality. And more recently, the Yikisang district of Jilin province, up near the North Korean border, is described in an article I read, and is the formation in which these peridots are found actually sort of drives right through into the area of North Korea. However, the Jilin area stones are of much higher quality in terms of color. They're yellow green, but the ones on the Korean side tend to more towards a brownish overtone, and the clarity was quite high in these stones, and the yields are quite good. And they've actually they have for some time had cutting locations right near the plant, which is a good vertically integrated way of doing mining and producing of peridots, because they mine it, they sort it, and they cut it right in the same general area. And I borrowed, thank you, Jolian, an image of a Jilin 2-carat plus stone that was in gemdat.org to show you what it looked like. And it's quite nice looking quality. Now, Pakistan has become a pretty major source of good size quality stones. But like almost all the other locations for peridot, it's an extremely dangerous place to be mining. And as described in Phil's talk, if you look on the image on the left, you can see all these calcite-filled veins on a hillside above a lake in the high mountains. And it's those veins that are being mined. If you look on the far right picture, you can see all the holes that have been driven into the veining to search for the peridots there. And the miners live in extreme conditions at 15 to 16,000 feet. And apparently they make very rudimentary tunnels and rock shelters up there to live in during the short 3-month collecting and mining season. They've managed to move from hand mining to the use of compressors and power driven tools. But the trouble is, because of the difficulty of access to these areas, it can be up to 6 hours of very dangerous traversing of trails with going up to the sites by foot and by mule. So it's still relatively primitive mining, and yet this is yielding up some of the finest peridots in the world. And I thought this was an interesting posed picture on the left of a very handsome and proud looking miner hanging off the wall of a cliff, which is where an awful lot of the mining is done, on these sheer faces. And once they get a hole in there, once they dig into the veins, then they set up in that space sometimes if it's big enough, and mine in somewhat more comfort than they're in having to hang off the edges. And from the Sapit Gully location on the right, you see two pieces of rough and cut. Thanks to Clement Schwartzinger, that was my title page shot that I use as well. And as you can see, the quality of these stones is very high, and the quality of the rough is also very high. So, and the rough that's shown is actually a composite picture, because the rough is the rough that the stone in front of it was cut from. And Clemens is not only a good academician, but he's also a good cutter and a good speaker. He's spoken for us twice now. Now, Myanmar, excuse me, Myanmar has been producing some pretty fantastic peridot. I could not find an awful lot of data on it, and it's very frustrating to try and dig this out. The only authoritative source I could find on it was Ted Themelis, who's written the book. He's written the book on the mines in Mogok, and the book is still available. So you want to have it. It's actually a good addition to anybody's library to fill in your information that you might want to know about some of the finest mined peridot gems in the world. And he claims that the two open pit mines, that the Piaong mines, are producing very high quality material. But also, as was mentioned by Phil, this is one of those rare locations where you have materials that are being mined on the downhill slopes from where they've been eroded away from the mother rock, and it's collected from the scree. And so this is the hand mined open pit mines that are done there. The ore that is taken out is hauled away to a nearby very secure locality, because they know their material is worth a lot of money. And then, believe it or not, I couldn't believe this, they break it down with hammers, and then the nodules and crystals of peridot are separated and then cut. And for me as a collector, and particularly one who likes phenomenal stones, I was excited to hear that this area also produced a star peridot. And now that I know this, I'm going to have to try and find one to put in the collection, because I've never heard of that before, and I thought it was very interesting. And here's a picture of Ted himself. We share this picture of the mining, one of the mines in the mining area of Bernardino province. And he commented from his experience in recent times, there are a lot of newer small mines there that are illegal and unregulated. And if you look at the picture, you can see that the people have been mining a cleft. I don't know if you can see that or not, but you can see how they've been mining it down to the dump site at the bottom and pulling out the materials, and probably by hand. And I think if you look really carefully, you can see the miners over in that area there. But they do have modern equipment for hydraulic drilling and so on. It looks like it's on the back of a motorcycle. So I thought that was a very unique kind of a situation for people to have to mine. I mean, they're very innovative over there. I spent some time in Myanmar, but we were not fortunate enough to be able to go into the areas where they had the peridot mining. So Vietnam is also a location, and it has 3 provincial localities, of which Gia Lai is the most significant. And in that province, the Ham Rong and Bien Ho were the ones at the time of the article I read. They were producing over 100 kilograms of rough, of which 20 kilograms were of good gem quality. And I believe this has become far more developed since then. And this was back in the 90s, so we're talking many years. But basically they're found in alluvial deposits, as is the case in a lot of that area of Asia. And they've been obviously eroded down from the original basaltic sources. And the pebbles are not very large on the general average, being about 0.5 centimeter, but up to as large as 4 centimeters. That's a pretty good chunk of gem. The predominant color is yellow-green, and about 90% forsterite, and the rest is phthalate. And since this is a gem that comes from a mineral that is a chemical continuum that goes from magnesium to iron from one end to the other, the phthalate, I think, being the iron-rich end, and the forsterite being the magnesium-rich end. So you'll see more of a yellow color in the forsterite end, and most of the gem quality peridot in the world is mined is from that middle end of that solution series, sort of halfway between forsterite and phthalate. And the interesting thing is that unlike other gems, the color in peridot derives from its chemistry, its actual structural chemistry, rather than impurities. And there are very few stones in the world that actually can say that, as if they could talk. So, although this I thought was very interesting, although the Vietnamese areas are mostly known for their rubies and their spinels and so on, peridot is a much smaller player in terms of gems. And in some areas where the mining has actually almost dwindled to nothing, and therefore the local businesses have dwindled as well, that were all built up surrounding this economy of gems. I saw this as a special on TV the other day. There's a local entrepreneur who started a new business making gem paintings out of very finely ground up gem. And what they do is they buy all the stuff that the other guys don't want. Where they've cobbed off chunks that weren't really clear for faceting, and they've taken small pieces that were too small for cutting, and they pounded them up into very small pieces, and then they apply them piece by piece onto a painting and make really realistic, very, very pricey paintings that are totally made out of gems that are found in Vietnam. So in this way, nothing is wasted anymore, and so the very low quality peridot materials are now being utilized in a new art form. And I thought, when you take a look at the quality and the color in these gems I took from an update report by Pala Gems, I think that is close to the ideal color. And this is why, in some cases, people were confused when they saw good quality peridot, and they confused it with good quality emeralds. And so these are the Vietnamese stones have some of the nicest color I've seen in terms of saturation. Now, there is gem mining of peridot in the United States, and in Hawaii, which is probably the most tropically exotic and interesting location, because all the other locations are in rather dry desert-like places. So Hawaii is certainly a much more interesting place to look for and gather peridot, although they're considered to be the goddess Pele's tears, and if you take them away, bad luck will come to you. I'm not sure I believe that kind of superstitious thing, but every year thousands of examples of peridot and sand, volcanic sand that have been taken from Hawaii, are returned to the mail because people believe that they have been given bad luck by Pele, punishing them for taking away her tears. But in 2018, a rather interesting thing happened when Mount Kilauea erupted. The force of the eruption was such that many of the bombs that were shot out and some of the dust was shot out was sufficiently violently done that the little tiny contained peridot pieces were separated from the lava and rained down on the surface and were found. And you can see in the picture on the left, they're not very big, they're sub-carat pieces, but they were gemmy. And as was shown earlier, I think it's exactly the same picture actually that Phil showed. There's a beach called Papagalea, which is made up almost entirely of eroded tiny grains of peridot sand that have come out of the lava and the surrounding rock. And it's one of only, I think, 4 beaches in the world that's a green sand beach. But I've talked to some local collectors in Hawaii when I was over there, and they do have their secret locations where they have found and still can gather larger pieces of peridot, but none of them are as big as anything that's commercially available in other parts of the world. So it's not a commercially viable location, it's just an interesting location. The most productive location in the United States is the San Carlos Apache Reservation in Arizona, and it's on Peridot Mesa, where which is a basaltic uplift of some sort, and the cap on it is absolutely full of peridot veins and sections where they are hand mined using very primitive techniques by the local natives, indigenous tribal families, and they've been doing this for over 100 years, and some say over 1,000, because it used to be mined for use predominantly only by the tribal peoples, and now it's been exported all over the world, in many cases fobbed off as peridot from much more famous and valuable locations. But the average size of the stones here is relatively small, and you're not going to see very many stones over half a carat, generally speaking, but up to 3 and sometimes over 5. And the most exceptional piece I saw was in an article was 39 plus carats. And so and it was our ideal color. A lot of the material that's collected on the mesa is the less desirable brownish overtones. And with luck, he can be found in pieces, something like the piece that Phil showed you. It's very similar sort of a geological situation there, and the crusting of crystals, it looks almost exactly the same. And they do have some really nice green stones that are coming from there, and literally thousands and thousands of carats are mined every year, but in the most arduous and hand done way with pry bars and hammers. So it's not something you want to blast, although they have done some blasting, because it does damage the peridot, and it also flings what little peridot there is over a wide flung area and makes it much more difficult to collect. And you can see it's what it looks like on one of the mine sites there, and a good idea of what a good size group of San Carlos peridots look like on the right. But it's wickedly difficult terrain to work in. It's hot and very, very, very strenuous work. Now, as was mentioned, and of course we've already seen these pictures because they're ones that Phil used already, but there are locations in British Columbia, and I've collected it at the one near Lightning Peak, and I got a 3+ carat stone out of it, which is actually very unusual, and because most of the stones are much smaller. And the stones on the left are Phil's, and that's his rough and cut, as you already saw. And the one on the right was collected and cut by Brad Wilson from the Yukon location up near Whitehorse. And Brad Wilson is a very talented cutter, one of the coast to coast gem cutters who are famous for cutting unusual and amazing stones. So I come to the esoteric, those stones that very few people in the world will ever own, and I feel privileged to actually own one, that are found in palisite meteorites. And I found out the information I extracted came from a 1992 article by Sinkankas and others, and basically these peridots are found in populating stony iron meteorites called palisites. And they were originally described in the late 1700s by Peter Simon Pallas, and hence palisite. And this is literally, if you can get one, the most expensive and rare form of gem of the gem peridot. And although these stones, when you see them, are similar in color to and properties to all other earthly peridots, they can be distinguished, if one is interested to distinguish them, by a very fine lattice of right-angled inclusions within the stones. And most examples are under 1/3 of a carat, although I've seen ones that are 1 to 1.5 carats examples, but they're rare. And I think there's literally only 60 plus, very, very few, more than 60 known palisite meteorites that have ever been found in the world. So you can imagine in the world of peridots that this is a rare source of gem, not commercial at all. But I do want to give my thanks to the photographer Michael Bainbridge, cutter, photographer, and researcher Dr. Clemens Schwartzinger, and the gem curator of the British National Museum, Robin Hansen, Catherine Donnell of the ROM, and Ted Themelis for the use of their photos. And I have to admit, in my own amateurish way, I gathered information from a diverse source of online sources such as Gems and Gemology articles, Wikipedia, uh, and the Journal of Gemology, Knox Jewelers with Clarity Jewelpedia, as well as personal communications. So I'm grateful very much for the learning and information that I gathered from these sources and subsequently was able to share with you today. So if there are any questions, I would gladly entertain them. And you can open your microphones to ask any questions you wish.
It's me again, Reza Piruznia. I have an experience that I just, when I became a gemologist, I had a experience that if you want, I would like to share if they're new, like if there are new people to gems, that would be interesting for them.
Please do, just make it brief and concise.
Definitely. Yes, so I studied gemology at George Brown College with Don Warren, amazing professor. And right after I graduated from gemology, I traveled to Myanmar, Burma, and I saw this shop says olivine on bunch of nice, beautiful green gemstones. So when I asked the price, it was so cheap. I bought lots of them. And when I came back, I was like looking at them under the microscope and everything. I figured they're just quartz and they've been dyed or whatever. I still have few pieces available. So anyway, that was, I got fooled just because they said olivine, not peridot. And it was, I thought maybe they don't know it's really like the difference and maybe it's true. So I got fooled anyway. So don't get fooled by good looking gems and the names actually. Thank you.
Thank you for sharing that. And you know what? That's actually not an uncommon experience. A lot of people go into the gem fields thinking that everything they're going to see there is genuine, local, and amazing. And these guys are shrewd, some of these local people. They'll bring you in synthetics and imitants and put them out there with the other stones. And unless you go to a gemological center in the country of origin to make sure that they're what they are, it's buyer beware. And that's a very good lesson for anyone to learn when they're traveling, is that to buy your gems from reputable sources. And even though you may get it from a reputable source, get them tested by a reputable gemologist, many of whom are in the audience. Yes, Antoinette.
Yes, I just have to comment based on your comment. As a young woman growing up, child actually, my father, Tony Bonanno, Antonio C. Bonanno, as in whose name this award for excellence in gemology has been awarded since the year 2000, he used to say, the closer you get to the mines, the greater the incidence of fraud and misrepresentation. And in my very limited experience by comparison to his, I have found this to be the case. It depends upon where you are and what they know about you. If they know you are knowledgeable, it's a whole different interaction. But the moment they feel that you are not knowledgeable, and that you're just looking for a bargain or a quote, steal, stealing takes place, but not in the direction you think. So you're absolutely right. It's exciting to be at the source. But if you're not knowledgeable, and even if you are, and you're limited in what you can take with you when you're buying, you're hardly carrying your entire gem lab with you to these different sources. You need to test when you get home if you have the knowledge. And if you don't, your advice to get an independent gemologist to examine what you have and check for treatments or synthesis or total misidentification, whatever, is really critical. So thank you for bringing that up.
Well, I appreciate that very much, Antoinette. And it's true that but at the same time, you don't have to take too much in the way of instrumentation with you to do an awful lot of eliminating, like a good loop with a good light, a good dichroscope, and a couple things like that, or a Chelsea filter. these kind of things, even though they're basic.
You just mentioned the 3 items I never leave home without. Chelsea filter, Dyquist scope, and a good loop.
Good loop.
And
Yeah.
then I've also now added a portable version, battery operated, of a long wave, shortwave, ultraviolet lamp. You add that, and of course you have to carry your mag lights, different kinds of lights with you.
Yeah.
My little bag has gotten from pocket size to being large pocket size, but
Yeah.
with those portable instruments, you can very often know immediately what you don't have, which is as valuable sometimes as knowing what you do have definitively. But it really is, I'm glad you said it. There is a lot you can know for yourself. And it shocks me that more people buying gems do not use those tools at the moment. They're examining them and making buying decisions. They're portable, they're small, they're not expensive. And when you know how to use them, it's like each tool gives you a new clue,
Yep.
because every gem is a mystery until you solve the mystery. And the way you solve the mystery and know for sure is with the tools you use. And so many today are portable and really do a phenomenal job in helping you know what you're buying. So thank you.
And there are actually, although they're not always accurate, there are some very small instruments that can actually physically quickly identify quite a few gems.
Yes.
You pull these out in front of a questionable dealer, and immediately he starts to sweat.
Or tell you, wait a minute, he just got a new shipment that came in that might have something more to your standards, and they swoop stuff off the counter and bring you out a whole new thing. But also, I might also add, because this happened once, sometimes a dealer sells you something incorrectly, but not intentionally. I was at a major gem show. I had a client for a chrome tourmaline, a gem similar in color to peridot. Okay, but the point is, I looked at it and I was looking at 4 in the tray, and one didn't look quite right to me, but I pulled out my Chelsea filter and I pulled my mag light out, pulled the filter to my eye, and 2 went red through the Chelsea filter. And I know that chrome tourmaline has chromium, and it, in this case, will always go red through the Chelsea filter.
Yeah.
The deeper the red, the green, the redder the red, the lighter the green, the lighter the red. But 2 showed no red through the Chelsea filter. And I said to the man, excuse me, but you're saying all 4 of these are chrome tourmaline? Absolutely. And I knew him. I said, no, they're not. He said, what do you mean? I said, don't you have a Chelsea filter? He said, well, of course I do. I said, well, look with your own Chelsea filter. And he looked and he said, oh my, I won't use exactly the words he used. And he then pulled out his bill of sale from a major cutting house in Ida Oberstein, where he had purchased them all. And he had already sold 2. He had purchased 6 from this particular seller. And we already knew that 2 of the remaining 4 were not. And either somebody sorting tourmaline, they were tourmalines, all of them were tourmalines. Did somehow a few get mixed in with the parcel? Was it deliberate? Was some sorter pulling out the occasional stone and substituting a chip? We'll never know. But he immediately made a call. I was standing there to Germany to tell them what they had discovered, and they said they would resolve it after the show. But this is an experienced dealer.
Yeah.
He never checked what he was buying himself, because he was buying from a major cutting house in Ida Oberstein. There is no excuse for not using your tools wherever you are, whenever you are, because the bottom line is, when you sell that stone, whose reputation is on the line?
Right on. And I would add that this is an interesting, the reverse of this is that if you know your gemology, as is if you know your mineralogy, and you go somewhere and you say, oh my God, that's a painite. And the guy's selling it as a garnet or something, and say, well, I'll take that one.
Yeah.
But if you're honest, you'll tell, by the way, I just want you to know that that is not a garnet. and I'm not gonna give you a hard time over it.
Yeah,
But-
okay.
And a lot of times in gem lots in Sri Lanka and other knowledgeable gemologists have discovered new gems
Yes,
that weren't supposedly from there by noticing something was different.
Yeah.
And I know that Bill Pinch, a very well-known mineral and gem collector, would notice those sorts of things, and he could identify looking at the gem or the mineral and saying, that's not normal. I'm going to check that out.
you're
So-
absolutely right.
So if you use your gemology training, you can actually discover new things
Yes.
and get deals you never would have been able to afford otherwise, because these stones can be very expensive.
Yes, exactly. I mean, the more have you read my book? Because you're covering all the points I cover in why knowledge is valuable to anyone interested in gems and jewelry. But like the stone aquapraise, which was discovered just a few years ago, it's a member of the sorry, it's a member of the beryl family, but it's not aquamarine. It's not a chrysoprase. It's like a blend of the two, and it has been identified as a new gem. It's mineralogically a new gem from, I don't recall the exact location. I'm not sure I ever knew the exact location in Africa. But then this gem quality red beryl that was discovered, the pocket was discovered long ago, but not enough to make it worthwhile to mine. And then they hit a big pocket of it about 10 years ago. So we don't know what's going to come up out of the ground. New sources of known gems and so on.
Oh.
It's fascinating.
Anyway, although we didn't have the most exciting gem in the world this month, I thank you all for coming. And I will let you know now that on the last Sunday of September, we'll be having a program on sapphire, one of the most color diverse outside of spinel of the gems of the gem world. And if anybody here would like to let me know of a really good researcher / speaker on sapphires, I'd be glad to entertain them as a possible part of the panel. So thank you all for participating. And I just wish more people would do what Antoinette did today. And also, where'd he go? He's gone. Oh, Bezad, and share their experience and knowledge and questions, because it helps us learn. Goran, are you sitting in another world? All of a sudden you're sideways. And anyway, I really do appreciate your participation and your attendance, and tell your friends. And we'll grow this audience, because I do hope that we do give you more information than you may have had, and perhaps more interesting information. Thanks to Jolion for hosting us, and for also putting together archive copies of previous programs. It's a slow and painful process, but if you keep on checking on gem.org, you will see what he's already archived. And I think some of them are also on YouTube, are they not? Have you putting them on YouTube at the same time, Jolion?
They're all going onto YouTube, and on gem.org is just the links to the YouTube videos.
Okay, so if you've missed previous programs, look them up, and please participate in the next one coming up in September. I think you'll enjoy yourself. And thank you again to Phil for his contributions today.
Thanks very much.
And
One of
thank
those
you, Ray, for yours.
Yep. And have a great day.
Okay, thank you all. Bye.